Welcome to Business Math. This happens to be February 3rd, 2014. I want to make a couple comments about your quizzes that you're in the process of taking. You'll notice, I think most of you probably already noticed this, especially if you're taking the class online, there are 2 quizzes for every chapter. So you have your Quiz 1, for example, and Quiz 1E. Quiz 1 is 4 questions long. Those are either right or wrong. You don't need to show any work for those. And that's the Quiz 1 is where you get the 3 tries to do the quiz. Okay? The Quiz 1E is where that's the one that's E stands for essay. So that's the one where you show your work. And so just because you get the answer right, this is the one that I have to grade. So just because you get the answer right doesn't mean you automatically get your 2 points. And on the E, like Quiz 1E, Quiz 2E, Quiz 3E, and so forth, those you only get 1 try at. And then I will grade those because I have to grade those manually. All right. What we're going to do today, we're going to do a little review of some of the word problems in Chapter 3. We're also going to start Chapter 4, which is solving equations for the unknown. So I think, first of all, I want to get Chapter 4.1, Section 4.1, out of the way. And then, whatever time remains, we're going to go back and do some percent problems. Because I think percent problems give people a lot of grief, so that's what we're going to do today. So first of all, we're going to go to page 103 in your text, solving equations for the unknown. Now, one of the things that I want you to keep in mind when you're solving equations, and we're going to start off with solving equations with one unknown, is keep in mind that an equation is like a balance. It's like a balance. And the whole goal of solving for an unknown is that if we have, 2 of these unknown quantities over here, and let's say plus we have 3 more pounds here, and then it balances, let's say it balances perfectly with 11 pounds over here, okay? So here, if you think of an equation as a balance, so we have 2 unknown quantities plus 3 pounds, and let's say it balances perfectly with 11 pounds. The whole idea, when you do things to an equation, you have to do whatever you're going to do so that it balances. It balances. Now, usually this particular balance right in here would represent the equation 2x plus 3 equals 11. The reason we call this a linear equation, by the way, is because it's an x to the first power. And when you graph any line or any equation that involves x to the first power, you will get a line. That's what's going to happen. So, in fact, if you wanted to really to see the exact graph of it, you could actually graph this side, y equals 2x plus 3. You could graph this side, y equals 11, and you could actually see where they intersect, at what x value do they intersect. So that would be we may even take time to look at that so you can see a graphical representation, a picture of what 2x plus 3 equals 11 looks like. So we'll see if we get time to do that. So, whatever you do to both sides of an equation, you have to do the same thing. So you have to, for example, is it legal to take off 3 pounds off of both sides? Is that legal? Rachel?
Yes.
Yes, it is. That is legal to take 3 pounds off of both sides. If you take 3 pounds off of both sides, it's still going to balance, isn't it? So if you take off 3 pounds off of this side, take 3 pounds off of this side, in other words, subtract 3 pounds, and take 3 pounds off of this side, it turns out that it's still going to balance. Now, the equivalent of that is to subtract 3 from both sides. Now, the goal in algebra is to get the unknown quantity all by itself. So that's the reason why we take 3 pounds off of both sides first. Now, by the way, if you were so inclined, we don't recommend this in algebra, but I want you to get a handle on what's legal and what's not legal. It would be legal to throw away half of both sides. You could do that. You could throw away half of the right-hand side. You could throw away half of that right-hand side, and you would get 5.5 pounds over here. Then you could throw away half of the left-hand side. So throw away half the left-hand side, so throw away one of the unknowns, and throw away half of 3 pounds, which would be 1.5 pounds. This would be perfectly legal. It would be the equivalent down here of dividing both sides by 2. What I'm trying to get you to realize is that I don't want you to memorize magic. Now, usually, we don't do this. We don't divide both sides by 2 first and get 5.5 over here and get x plus 1.5 over here. That's not how we usually solve an equation. But the point is, I want you to realize it is legal because dividing both sides by 2 would give us an equivalent equation. Now, we could even do some very bizarre things. We could triple both sides first if we wanted to, if we thought that were advantageous. And in fact, in cases that involve fractions, I love to do that. If we have fractions that involve, let's say, a denominator of 3, we'll do that. The first thing I'll do is I'll multiply both sides by 3 to eliminate all the fractions. It turns out, if you want to, you could square both sides. If I had some ugly square roots that I was looking at and I wanted to get rid of those square roots, I could square both sides if I thought that were advantageous. I'm going to put this back to where I had it. But the point is, whatever I think is advantageous, I can go ahead and do that as long as I do that to both sides. If I think it's advantageous to cube both sides, raise both sides to the 3rd power, I could raise both sides to the 3rd power. Because if I cubed the left-hand side and cubed the right-hand side, it would still balance. All right? If I wanted to take the square root of both sides, I could take the square root of both sides. I think you get the point, right? So whatever I want to do to both sides, as long as I do it equally to both sides, I'll get what's generally known as an equivalent equation. Now there's some complicated things and so forth that we'll go over a little bit later when we're dealing with more complicated equations. But the standard way of solving this equation is, first of all, subtract 3 from both sides. So we'll do that. Subtract 3 pounds off of both sides. Now, 2 of my unknown quantities balances with 8 pounds. So what's the next thing I do to both sides, Courtney?
Divide it by 2.
Divide by 2 is correct. So I divide both sides by 2. So I take the left-hand side divided by 2, the right-hand side divided by 2, and that's the equivalent of throwing half of the left side away and throwing half of the right side away. And now my unknown quantity is balancing with 4 pounds. So way down here, I get x equals 4. Now the reason that I wanted to make such a big deal about that is because algebra is not magic. Algebra is not magic. And I don't want you to realize that, I never was good at algebra because I just couldn't memorize all the rules. That's not it. If that was your approach to algebra before, now I don't want to go Richard Sherman on you, and that would scare us all, wouldn't it? But he calmed down a little bit after the game last night. I mean, poor guy. I hope he didn't break his ankle or something like that. But anyway, this is, by the way, for you online students, the Super Bowl was just last night. So I don't want to go Richard Sherman on you to emphasize this, but it's not magic, okay? There are principles that hopefully you're going to understand. You can add the same thing to both sides. You can subtract the same thing from both sides of a balance. You can multiply both sides times 7 if you wanted to. And in fact, let me show you an equation. Say, gee, aren't you going a little bit crazy on this? Well, watch. If we have this equation like this, that has a situation of 2/7 x plus 9 equals 42, all right? I don't like fractions. I don't know about you, but I'm not a fraction lover. Okay, I'd much rather deal with decimals, whole numbers. So the very first step that I would do to this, I don't like fractions. And by the way, one of our problem-solving strategies that you hopefully wrote down in your notebook was to make the problem easier. Now, when I multiply both sides times a 7, that definitely makes the problem easier. When I multiply both sides times 7, now again, you have to understand a few other principles. When you take 7 times the left-hand side, you have to use a very important property called the distributive property. Okay? You have to take, because see, there are 2 terms here. There are a few things that you do need to understand. This is called 2 terms because it's separated by this addition sign. So terms are separated by addition signs and subtraction signs. Now to contrast that, if we had this equation, I want you to see the difference. If we had 2/7 x times 9 equals 42, yes, I can multiply both sides by 7 to get rid of that messy fraction. This is an entirely different equation. That's why I'm doing this one in red. On the left-hand side of this red equation here, you don't do a distributive property. We do what's called an associative property. An associative property is because all of these are terms. 7 is a term, 2/7 x is a term, 9 is a term. In fact, if you really wanted to, when we say 2/7 x, it's 2/7 times x. So you can call 2/7 a term, x is a term, and 9 is a term. But it's way, way different than this up in here. Up here we have 2/7 x is a term, and 9 is a term because it's separated by a plus sign. I realize that I'm making a real big deal, especially for those of you that are good at algebra, and I apologize already. But that's why when you have 2 terms, you have to take the 7 times the 2/7 x term, and then you have to take the 7 times the 9. That's the distributive property. This down in here is the associative property. If the associative property says you can take 7 times, and you can first of all take the 2/7 x times 9 and then times by 7, Or you can take the 7 times the 2 sevenths x first, then times the 9. But you don't distribute the 7 down in this red equation here. You don't distribute it because there aren't 2 terms down. All right, well, hopefully that was so easy I about put you to sleep, huh? Now, let's see, 4 times 7. I used to be good at math. Shay, what's 4 times 7? Or 7 times 42. I used to be good at math.
294.
294. So, let's see, 428, damn 14. Yeah, 294. I think I agree with that. So in this case, now, be very careful. Again, can't emphasize this enough. I don't want you just magically canceling things. If you can't tell me, in fact, if you can't tell me why you can cancel that 7 with this 7, if you can't tell me why you can cancel that, then you can't use the word cancel. Ooh, I'm getting picky. And Jonte, don't make me go Richard Sherman on you, okay? Now, why can you cancel the 7, Jonte?
Because you said why you can't?
Yeah, why can you cancel the 7?
Because they're the same number.
That's a good answer. I like it. I like the answer. I love it, actually. They're the same number. Okay, I'm going to put 7 is really 7 over 1. And really, what's going on here is we're dividing this numerator by a 7, getting 1, and we're dividing this denominator by 7, and we're getting a 1 here. So it's really because we're dividing numerator-denominator by a 7. All right? So, beautifully, what that does, it eliminates the fraction. It eliminates the fraction. And so to finish this particular problem, what would you do to both sides to finish 2x plus 63 equals 294? How would you finish? What would you do next, Robert?
Subtract 63 from both sides.
Very good. This is just almost boring. So you subtract 63 from both sides, and then the very last thing you would do is what, Rachel? After you subtract 63 from both sides, we get 2x is equal to, I believe, 231. So what would be the next thing you'd do, Rachel?
Divide 2 by both sides.
Yeah, divide both sides by 2. So take both sides, divide by 2, and you'd get, looks like about 115.5, okay? 115.5 when you did that. 115.5. Now, one of the things in the UDI process, the problem-solving process, from George Polya, understand the problem, devise a plan, implement the plan, and the E stands for what, Robert?
Evaluate.
Yes, evaluate. So you have to evaluate your solution and the plan. So you're going to have to take this 115.5. This is not too fun, is it? And you're going to have to plug it back in for X. Okay? So, let's see, very quickly, let's see if we can do that. I'm going to take my handy-dandy calculator, and I'm going to take 2/7 times 115.5. So I'm going to take 115.5. Now, how do you do that on your calculator? How do you take 115.5 times 2/7? Shay, how do you do that?
You use this little button that looks like a backwards L to make the fraction, and then you times it by 115.5.
I had to turn up your volume. Now, say it one more time. How do you take 2/7 times 115.5?
Divide 2 by 7 and times it by 115.
Oh, that would work. You could do that. You could actually take 2 divided by 7 right there. That would work. Very good. And now the only problem with that, 2 divided by 7, and probably this will be close enough. Hey, the problem with 2 divided by 7, it's a repeating decimal, isn't it? Because you get 0.28571428, and it keeps going forever and ever. So, but it's probably close enough. So that would work fine, Shay. In fact, let's go ahead and do this with your method that you first of all did. 2 divided by 7, so I got the 0.2857 blah 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 times 115.5. Okay. Now, if you notice what my calculator at least got for an answer, I got 33.00000000003, and that's what that is. That last 3 on there is a rounding error. All right. That's why if you did 2 divided by 7 first, it's okay, but realize you're probably going to introduce some rounding errors. All right. Probably realize you're going to introduce some rounding errors. So that 3 way out there, way out there on my calculator is as a result of a rounding error. Now you can take this and add 9 to it and see if you get 42, the original answer. And I got 42.00000003, which that's close enough, right? See, close does count. Hand grenades, horseshoes, and on dates, right? See, I'm so old I can still remember. By the way, after you get married, you still keep dating your wife. I had to say that to some of you guys. You keep dating your wife, okay? Not other. Your wife doesn't like that when you date other women, usually. But anyway, so that's close. Now watch the difference of what happens, however, if instead of taking 2 divided by 7 first, watch what happens if we take the 2 times the 115.5 first, then divide by 7. I don't think we're going to get that rounding error. It's not a big deal. You just need to be aware of rounding errors. So 2 times 115.5, boom, we get 231. Now divide that by 7. We get 33. Then add the 9, and we get 42. But regardless, one of the things that I learned very quickly, the reason I just really ended up liking algebra, is the fact that you can plug your answer back in for X to see if you got the right answer. I mean, wouldn't that be cool if in history, you'd say, all right, when was the War of 1812? That's not too hard, though, that one, right? So when was the Civil War? And you could you take your guess even. Now they'll plug the number back into some formula and you say, oh, okay, I think, yeah, that's right. But you can't do that in history. You can't do that in history. Well, you're going to have to read your book carefully because I want to spend some time to go back and talk more about percentages. But look at page 105. Isn't this amazing? What picture do you... Oh, you have your book with you, don't you, Courtney? What picture do you see there in figure 4.1 on page 105?
A balance.
A balance! Well, lo and behold, great minds think alike right there. Oh, look at this other principle, solving for the unknown rule. It's about 3/4 down the page. About 3/4 down the page, solving for the unknown rule. What does that say, Jonte?
solving for the unknown rule. Whatever you do to one side of an equation, you must do to the other side.
That is awesome. See, I could have had you read that with a Richard Sherman impression, but it's too early in the morning, right, John Tay? Oh, man. Yeah, well, it's definitely too early. I've already talked to you about order of operations, but on the bottom of page 105, it talks about order of operations again. Now, the order of operations that I'm going to give you, in fact, I think I gave it to you before, PP, MD, AS. Pretty please, my dear Aunt Sally. Or pepperoni pizza makes Dad awfully sick, all right? But you get the idea. This was parentheses. So when you have this big expression, 2 plus 3 times 4 divided by 2 raised to the 4th power, something real messy. Parentheses first. So the very first thing that you would do in this particular expression is you would take the 3 times the 4 first. You have to do everything inside those parentheses first. The next thing you would do is the power over here. So you'd raise to the 4th power. Then the multiply, this is actually multiply or divide in order from left to right. So you just take it from left to right, multiply or divide. So the next thing that we would do is we would do this division right in here. So the first thing we would do is everything inside of these parentheses. That would be number 1, first thing. Second thing is the powers. The third thing we would do is multiply or divide in the order from left to right. So the third thing is we would do this division right in here. And then the last thing that we do is the add or subtract in order from left to right. So the very last thing you would do is the addition right in here. That's very important for you to realize that because you get your order of operations. And if you look at the bottom of page 105, that's in essence what I just went over right there. Well, something else that's extremely important in algebra is the combining of what we call like terms. The combining of like terms. This is extremely important to realize this. So if you see an algebraic expression, let me put an algebraic expression back up here. So I say 2x plus 5y plus 3x minus 8y equals 17. Well, there's an equation. Now, for one thing, that's an equation with 2 variables in it. So this is a pretty complex equation right in here. All right? But it's got 2 variables in it. Well, the first thing you got to do is you got to get all your like terms together. So 2x is a like term with what? Shay? 3x. So 2x and 3x are like terms. So you can add those up. So what is 2x plus 3x, Shay?
5x.
5x. You can get those together. And then our other like terms, Robert, are what and what?
5y and 8y.
Yeah, 5y and a minus 8y. And by the way, it doesn't matter. This could be thought of as a plus a negative 8y, couldn't it? Because then you don't have to worry about the order. For example, see then 5 minus 8 is not the same thing as 8 minus 5. That is called the commutative property. Now we have a commutative property for addition. So for example, you can do, for addition, you can go 2 plus 3, that's the same as 3 plus 2. That's the commutative property. The way commute means like, hey, you leave home, you go to school, then you leave school, and you go back home. Okay, commute. You go from point A to point B, then you go from point B back to point A. That's a commutative property. Commutative. There is a commutative property for addition. There is no commutative property for subtraction. By the way, is it important to learn the names? Yes, because you see, that's part of learning a discipline. Part of learning a discipline is you learn the correct vocabulary. Because if you don't know the correct vocabulary, even if you're doing something where you say, well, it's not that important to know. Well, in communication, it is important to know. Because I'm going to be going to a conference, giving a speech at a conference in April. It's an international conference. And the title of my presentation is an analysis of the trading of short, vertical, credit bull put spreads using leaps. Now, what in the heck did I just say, Rachel?
I have no idea.
That's right. Because, see, you don't know what all those words mean in their context. I mean, you know what the word short is? Hey, you have a short, weird math professor teaching you math every Monday, Wednesday, and Friday at 8 o'clock. But in the context, short in the area of trading just means that I'm selling something before I actually buy it, or I just sell something. Short, that's what that means. Long, in trading terms, means you bought something. Sell means you're shorting it. It's short. And a bull put credit spread, well, a credit spread, you have to know what a spread is. And then you got to know what a credit spread is, etc. You get the point. So when you're talking in a discipline, you have to learn the language. So yes, I do want you to know the commutative property. Yes, I do want you to know that 2 plus 3 equals 3 plus 2 is called the commutative property. I want you to know that. Because that way when we talk about things, then we can say, oh, okay, the addition has the commutative property, but subtraction does not. So it's easy to see that 2 minus 3 is not the same thing as 3 minus 2. That's not the same thing. There is no commutative property for subtraction. And then it's important, I already told you about the distributive property. 2 times 3 plus 4, that's the same thing as 2 times 3 plus 2 times 4. That's called the distributive property. We usually say it's the distributive property of multiplication with respect to addition. So we're distributing the 2 to the 3, and we're distributing the 2 to the 4. One other property I just hinted towards was the associative property. And the associative property means it doesn't matter which ones you associate first. So if we take 2 plus 3 and add those first, then add 4, it's the same thing as if we added the 3 plus 4 first, then added it to the 2. Now you notice on the associative property, the order does not change. 2, 3, 4, 2, 3, 4, but our grouping does change. So we're associating the 2 and the 3 first over here, then we're associating the 3 and the 4 first over here. So that's the associative property. All right? Those are some terms that you do need to know. Well, when we get our like terms together, we take 2x plus 3x, and we get 5x. Then we get our like terms together of 5y and a minus 8y. The reason I changed that to plus a negative 8y is, like I said, now we don't have to worry about the associative property we don't have to worry about commutative, because we don't have to worry about subtraction. So we have a 5y plus a negative 8y is a negative 3y, which is the same thing as plus a negative 3y if you like. Anyway, there's a simplified form of this equation. Now this equation, actually, if we graph this with ordered pairs, it actually graphs as a line, and we'll talk more about that later. All right. So your author gives you the mechanical steps in solving. Your author tells you about the distributive property. Okay, that's some good stuff. And I think that's all I need to talk about today on the algebra. I have about 8 more minutes to go back and talk a little bit more about percents. Tell me what 27%, what does that actually mean, Rachel? 27%. What does that mean?
It's 0.27.
Excellent. That means the same thing as 0.27. Now, tell me give me an example of what 27% means, Robert.
What do you mean by example?
Oh, in real life. Either give me an example of 27% in real life.
Is 27 cents is 27% of a dollar.
Very good. That is excellent. The 27 cents is 27% of a dollar. Now, one of the things, as far as the language of percent, your author spends a lot of time in this in section 3.2, and I hope you read it carefully, because the language of percent is very important. You see, we say, here's some language. 27 is 27% of 100. Okay? Now, one of the things, I didn't spend much time, or hardly any time, with translating a sentence that involves percent into an equation. That's why I want to spend the last about 6 minutes here. 27 translates into equals. Then, Rachel, we're going to borrow what you told us, that 27% is 0.27. Of means times, so 27 is equal to 0.27 times 100. And that is a true statement, isn't it? True statement. By the way, for you online students, I didn't make this clear, but when I say a rhetorical question, when I say, isn't it, see, I didn't call on Rachel, I didn't call on Jonte, I didn't call on Shay or whatever, so you don't have to type that question down. So when I say, wasn't it chilly this morning? You don't have to type that question, okay, online students? Or if you're making this class up for you live students. All right. Translating a sentence into mathematical language. So let's continue. All right? Let's continue. Let me take another example. What number is, well, I don't want to make it too hard just because I don't want to get lost in the numbers. What number is 30% of 1,000? Right? Now, to translate that into an equation, let's go ahead and do that. All right, let's translate that into an equation. What number, let's translate that into some algebra. What do you want to translate that into, Courtney? Because we don't know what it is, right? So in fact, what symbol do we use in algebra when we don't know what the number is? X. Oh, by the way, when we've learned when we teach algebra to little children, we use n instead of x. See, x. That sounds scary, doesn't that, Jonte? X. You know, and then the skull and crossbones on the poison, you know, X. That sounds scary. but N. So we've learned when we teach small children algebra, we use N for the unknown. We say N. Okay? So if you're scared, you better use N, all right? All right, X. Now, is, we translate that into what? Okay? Equals, very good. All right, translate 30% into a decimal, Jonte.
Point 0.03.
Well, that's a good question. Is it 0.03? Is it 0.30? Is it 3.0? Is it 30 point?
0.30.
0.30, very good. Of translates as what? What's of translate as, Jay? See? Time. And we usually in algebra we use a dot instead of an x because we don't want to get confused with x. So that's how we translate that. So x is equal to 0.30 times times 1,000. So when you take 0.30 times 1,000, you got your answer. So you move the decimal point 3 places to the right. That's the quick way to multiply by 1,000. So you get x is equal to 300. It's very important to know how to translate. Very important to know how to translate. I only have about 2 minutes left. All right, so let's do some more translation. And I'm going to come back maybe even do more on Wednesday with this percent stuff because it is very important. If I say, what percent is 4 of 12? Oh, man. Now I'm starting to mess with it, right? Or we usually even say that, we rewrite this first as 4 is what percent of 12? That's the first thing we would do in this problem. When it says what percent is 4 of 12, you would rewrite that. I would recommend that you say 4 is what percent of 12. Because now what you do is you just write this in algebra. 4 is translates to what, Courtney? Equals. What percent? We have no idea, so I'm just going to say n. I won't scare you as much this time. Of 12. Four is what percent of 12? And of translates to times, so n times 12. Okay? Now we would take this equation right in here and divide both sides by 12, wouldn't we? Divide both sides by 12. And so we would get 1/3, which is 0.333333, is equal to n. But now we're supposed to translate that into percent. So what's 0.333 as a percent, Shay? What's 0.333 as a percent, Shay?
33.3%.
Yep, 33.3%. So that would be your final answer. 33.3%. You guys did great today. Awesome. I will see you on Wednesday. And for you online students, just pay attention as to when your quizzes are. There are 2 quizzes for every chapter. You have your 4-question quiz, which you get 3 tries to do. And then you get your essay quiz, which you get 1 try to do. All right? Good luck. Call me on my cell phone if you have any questions, you need any help.
Dr. G,
Yes.
Well, you said you want us to show our work on that essay question, so what if we
Absolutely.
just write the question down and then how do we...
I'm glad you asked that question. You can do this all with paper and pencil and then take a picture, but make sure I can read it. Okay? So if you want to do it that way, or if you want to type showing your work in Blackboard, whichever you want to do, it doesn't make any difference to me. Okay?
Okay. All right.
All right.
Thank you.
Yep. Have a great day.